So the AWS are providing pre-trained AI services with ready-made intelligence for your applications and workflows. So AWS provides a comprehensive suite of AI services that empower developers to integrate AI capabilities into their applications effortlessly. So these are some of the names of the applications. Like we have Amazon Lex for building chatbots. We are going to create one in the next session. So we have Amazon Recognition for deep learning based image and video analysis. We have Amazon Translate, we have Comprehend, we have Poly, we have Transcript, and we have furthermore to Deep Racer and Deep Composer, etc. We'll explore that too. These are some of the interesting things to watch, but also you can go and create this on your own to that level with your machine learning knowledge in future. Okay, so that's what I'll be suggesting you. So let's continue and start with Amazon Recognition. Okay, so Amazon Recognition, you can identify objects, people, text, scene and activities in an image and video, as well as detect any inappropriate content. So Amazon Recognition also provides highly accurate facial analysis and facial search capabilities that you can use to detect, analyze and compare faces. So this recognition is for image processing task. So whatever we are seeing here, you can do the same on your own, but you have to do with OpenCV, which is Open Computer Vision, a library in Python. With that we have neural network, convoluted neural network, right? So for image based task we can use these combinations and then achieve these kind of activities. So they are providing their service too. So they have a lot of services like they have mentioned, so we'll see about that. So Amazon Recognition, they provide deep learning based image recognition service, like you can detect object and scene, facial analysis, face comparison, celebrity recognition, face recognition, etc. So you can achieve these things. Also not only image, so they also have video analysis. So if you upload a video, so video is nothing but frame by frame we are having images. Okay, so that will be analyzed and it will give you output of what is present in that video, who are all it can find, what all object it can detect, etc. So this is going to be one of the interesting tasks, so we'll see that. So let me go into my console, and before using that, please check the free tier, AWS AI Services. So if you go and check it, the artificial intelligence services from machine learning, so you can see the cost of it too. Free tier. Okay, so these are the products and how many free tier they are offering. So you see, like Amazon SageMaker is also one of the AI services from them. You have 2 months free trial, so please note that. So since if you have started with the course with us, now 1 month is about to complete, right? So you have 1 month free trial left, and other things they have free trial, so please make note of it. Whenever you are going to use something, please go and check it, and then if you are okay with that, please proceed with that further. Okay, so you can also find in the services, if you go and search for machine learning, so you have all these things which are AI services, where you have your SageMaker too. So it is also one of the machine learning AI services they are providing, and we have recognition, which is for search and analyze image. Okay, so let me go into it. So you can try demo, and you can use an API too. So if you want, you can integrate with your applications too. So let us start with label detection. So it is having some sample image, so it will find labels in your image, which means, see here in this image, it is detecting a building. Okay, it is detecting cars. You can see it is detecting these as cars. This is a skateboard. This is a person. Okay, tree is not recognized. So some of these things are detected. Okay, you can see here. Okay, so these things have been detected, and their percentage, how much it is, confirming it, you can get it. So another sample image, see here, this should be a city and the ocean. Okay, it is detecting, okay, tower. Other than that, it is describing about it. See here, building, city, cityscape, office building, water, high rise. Okay, I don't see any boat. Yeah, there is a boat, it seems so. So yeah, it's detecting that too. So all these things are available in this image. So if you wonder, if you want to try it, you can go and use this too. So how this is working is, remember previously we have seen one project which is dog versus cat identification, where if you give an image it is going to predict dog or cat, right? Then the same way you can train a CNN with a lot of images, but the data is important, because there for dog and cat itself we have used 25,000 images each. But then imagine how much data you need here. So whenever you are matching something, you can give a box to it and then describe about it. So that's how this thing works. So you can go and upload your own image too, and then search. For example, I'm having some sample images here. So let me use this image. So it's detecting a soccer ball, football, person. So they have been detected. Apart from that, clothing, footwear. So it's detecting the shoes, etc. These are all the things it has been detecting. Okay, so you can go and upload some other image too and check. We'll use this. Okay, jeans, jacket, helmet, man. Other than that, workers. So it's trying to get the scene. So that's how this thing works. So this is for label detection. Okay, so you can also go and use this option, which is image properties. So if you upload an image, it is going to give you what is the dominant colors, what is the foreground and background property colors. Okay, you can download this for an image. So what are the colors, etc. You can extract details from this. Okay, so you can upload your image too and then get the information from it. Okay, so if I pass this image, let it upload. It will give you what are the colors available in it, what is the foreground and what is the background colors. Okay, and then we have image moderation. So this will, like, if you have an image where it contains some explicit or adult content, so what it will do is it will blur that content and give you some results whether it is predicted or not. Okay, and that's what this image moderation will help you to. You can automate that task. And then it's facial analysis. Okay, so if you pass an image, it is going to give you the facial analysis, which include details such as like it's look like a face. Okay, appears to be female, and the age range it is giving to 25 to 35, and it is telling not smiling, appears to be happy, wearing glasses, wearing sunglasses, eyes are open. I don't know how it's predicting eyes are open, but still mouth is open. And other details. Okay, so we'll go with this sample image where you have multiple persons. So you can go and select the person and identify this. So it's look like age range is around 6 to 14. Okay, here the age range is around 23 to 33. Here it's 23 to 31 years old, female. So it is detecting all these things. So you can upload your own image too. So let us check with that. So we'll go with this image. Okay, it is giving you the predictions. Okay, and here, so you have those predictions. This is what the facial analysis is. And we have celebrity recognition. So if you upload any celebrity image, so it is going to give you who it is matching. Okay, so we have some sample image of Jeff Bezos and Andy Jassy. So you can add your own image too. So that's why I have these images. So let me add this. And this is predicting this as Cristiano Ronaldo, celebrity, and then Maxim Chanot. Okay, and we'll try with some other images. So it's giving Vin Diesel and Robert Downey Jr. It's matching perfectly. Fine. And you can also go for face comparison, which means if you have two images and if you want to find whether this person is in this image, whether both are matching, so it is going to take the property of the face. So first it is matching with this face. Okay, it's not equal with this face, it's not equal. These two are matching, so it is giving you they are the same person. Okay, you can go and use that too. For this person, we can find this matching with this person, so it's giving you accurate result. So we'll try to add some other image and check. For example, Yeah, I'll go with this image here. So now it's not matching with anyone. I'll upload this image, so we'll check whether both are matching. Yeah, its similarity is equal to 99.8% similar, so it is matching perfectly. So let's try to confuse it with some other image. So with both of this image, so let us try whether it's matching. So it's not matching with Vin Diesel, it is correctly matching with Robert Downey Jr. And that's how this thing works. It takes the facial analysis. Even though you compare, you are going without hair image, but still it's predicting correctly, right? Only the face features. And you can play and check with this too. And you can extract text in an image. Okay, this is actually available. You can do it with Python too, with the help of PyTesseract. Okay, it is from a usage of OCR, optical character recognition, and they are providing this too. So you can pass an image and the text in it can be detected. You can see, right? So let us try to upload our image. So I have some sample image here, and you can see it is taking all the words from it. So you can use it for this task. And then PPE detection. So PPE is something like personal protective equipment detection. So we have some of the companies where industries, chemical industries and like hardware industries where the machineries are there. The employees or the workers have mandatorily they must wear these PPEs, which is personal protective equipment. It's mandatory. But sometimes the human, they used to tend to not follow some things without caring about their safety. Okay, so they'll be having some supervisors to manually watch them. So in such case, what they can do is, we have this task. Okay, this is for image. You can have it for video too. Okay, you can apply this in video too. First, let us go with image. So what this PPE detection will do is, it will try to match the PPEs, whether they are wearing or not. Okay, so you can set some alert in the video, which means if they are not wearing, if it finds any person is missing this PPE, then it can give alert and to the superior. So that's how this thing works. So we have some multiple images here, and it's detecting the things, right? So you can upload your image too. We'll go with this image. So you can have the required PPE, the head cover. Okay, so it's matching face cover, etc. So you can change the person and see how much they are wearing, whether they are wearing positive or not. Fine. Yeah, so that's what with image demos. So you can have some in stored video analysis too. So if you have a stored video, see here they are providing some sample video. Let us see a little glimpse.
Say incompletely informed, you better start working on changing your business model. Absolutely.
So we have celebrities here, Jeff Bezos and some other person. So you can, if you don't know, you can check. This is Vernal Vogels. Okay, and it is give you, if you pass a video, so it is going to detect the objects. You can get, okay, the crowd. You can see here the crowd it is giving you, but it may match or sometimes it may not match. Okay, and yeah, like the quote, you can get the quote here. So it will detect objects from this and give you the timeline where it is present. Okay, and that's how this thing works. So the people, celebrity, object detected, and any moderated content. So if it is available, it is going to show you automatically. And you can upload your own video too. Okay, so I'll go with a sample video. I have this video, you can upload it directly. So I have already uploaded it. Okay, if you go with your own video, you can just click and drag drop it from your system and it is going to take that. Okay, and I had this video. So let us run this and verify like whatever it is giving. Okay, so this is a cricket video. So it is going to take some time to run, and once it is completed, we can see it is predicting one celebrity, Virat Kohli, and the objects, if you see, so it is giving me like it is even predicting the tattoo. So if you go and see in that timeline, we can find. Okay, and instead of, other than that, we have like cricket bat here. So wherever it is matching the cricket bat, you can see. So it is giving you the timeline of the bat, which is predicting. Okay, and then other than that, we have other things, etc. Okay, you can go with show more, and you can see outdoors is predicted here, the stadium. Okay, you can also have field, which is the ground. You can see it is matching here, right, the stadium. So that's how it will predict the things present in the video and the peoples, etc. Okay, totally you can have all the results here. Okay, what all it's matching. And that's about the stored video analysis, which means you can upload a video and then analyze it. You also have streaming video analysis, which means like you can this is a service you can purchase where it's real-time based video analysis. So if you have a CCTV, then you can pass it. See here in this CCTV footage, whenever it is finding something, so it is detecting person and a package is being detected. Okay, so you can have multiple things here. So let us run this video where it is detecting a pet animal. So whenever something moves or abnormally found, it is going to give you alert of whatever the thing is. Okay, so that's what streaming video analysis is. So whenever it is detected, it is going to give you a person. Okay, and other things. So this is how this streaming video analysis works. Imagine this PPE detection in an industry. If they have a CCTV footage and where they are directly passing it to this PPE detection through the streaming video event. So what will happen is whenever someone's not wearing any kind of proper protective equipment, it is going to give alert to them, right? So that's how this image recognition, Amazon recognition is working. So you can also try your software development kit and integrate with your system too. Okay, so that's what about Amazon recognition. We have seen about the video analysis too. So next, going into the next part, which is Amazon transcript. Okay, so Amazon transcript is an automatic speech recognition service that uses machine learning models to convert audio to text. So this is speech to text, and you can use Amazon transcript as a standalone transcription service or as an add speech to text capabilities to any application. And you can start streaming and then you can get your output. For example, let us use the transcript. Powerful speech recognition. Okay, I'll just delete it and recreate. Yeah, first the real-time transcription, you can start it. So once I start it, see here, I'll allow it. Yeah, it's asking me to start speaking, and I'll try to speak a little bit faster and it is guessing a little bit correctly. So you can see the results. So that's what Amazon transcript is. It is for speech to text recognition. Sometimes it goes like, see here, instead of transcript it is going something like Amazon plant grippers. Okay, sometimes it will be a little bit good, but when you are going in a normal pace, it is going to be absolutely best form. Okay, so you can download this too. So whenever if you want, you can if you are speaking, if you want transcription, you can download this too using this option, or you can just clear this. We also have the transcription job, so which is for you can create a job. For example, we'll just try to do something like subtitles generation from a video. So we are going to pass a video into it, and then what it is going to do is it is going to use the same method to generate a subtitle file directly. So with that, we'll attach it with our video and try to check whether it is working properly or not. Okay, and let me go into the transcription jobs now. Wait, I'll load it. Transcript. Yeah, so in the transcription jobs, so let me just create a job. So if you want to create a jobs, you can go with transcription jobs. So here I'll add some name, subtitle generator. Okay, so you have to give your input data, you have to store it in the S3. So I'll have just stored it in my S3 one video. So yeah, I'll add this video, I'll choose this. And the output, it is better to go with specified bucket. So let me give the same bucket. Okay, this bucket. Okay, so we need which format you want. I'll go with both of this and then click next, and then you can go and create a job. So what this will do is it will take the audio and it will convert the text into speech. Okay, speech into text, where you will be getting a file, a subtitle file properly with the timeline. So with that you can directly attach it to your video. So it is going to be exactly matched in that place. So we'll see it, the subtitle generator. So now it has been complete. So let me go into the output data location, and we can download and try to attach it. See here, just now it has been created. So I'll just go with this SRT file. I can go and download it. I'll download this both too. First let me download this. Let it download. I'll cut this and proceed with the folder. So what I'm going to do is I'll just open this with some other player and then attach this subtitle file. And you can see here there is no subtitles right now, so I can go and attach the subtitle file. So let me just attach it, choose the subtitle file, and here we have the subtitle generator, that file. So if I play this, we should get some good output. We'll check.
It's the perfect arc, crashing to Care corner.
Just 2 deliveries. They took him to the side. Oh, it's gonna go.
Well, that had a flight number attached to it.
You can see we had subtitles generated, and it's a little bit good, right? It's matching good.
She set back, he waited. From Jason Holder, he wants plenty here from the West Indies at the back end.
105 meters. That is the biggest hurt.
It is actually producing really good output, right? Yeah, that's it about Amazon transcript. So we'll go and see the next one. Next we are going to see something about Amazon Poly. So Amazon Poly is a service that turns text to lifelike speech. So previously we have seen about speech to text generator. This is text to speech generator, and this is lifelike speech generator, which means like it will try to give you a real human speaking experience. So enabling you to create applications that talk and build entirely new categories of speech enabled products. And Amazon Poly is a text to speech service that uses advanced deep learning technology to synthesize speech that sounds like a human voice. They have their own Alexa, right? Amazon Alexa, the speech capability. So likewise they have some other voices too, and you can go and use this Poly to create text to speech. So we'll try that too. So if we go into the console, and we'll go with Poly, turn text into lifelike speech. And some of these are available in some regions only, so some of these services will be only available in North Virginia. So if it's available in your region, AP South 1, it's okay, or whatever region you are using. So if you don't have, it will suggest you to shift to this region and use it. So make note of that too. So we'll try to listen to this.
Hi, my name is Joanna. I will read any text you type here.
We'll go with the standard one.
Hi, my name is Joanna. I will read any text you type here.
Yeah, we'll go with the neural itself, and you have some other voices. This is English US voice.
Hi, my name is Justin. I will read any text you type here.
So this is from like a boy, a small boy voice. You can change this to, for example, you have Indian English. So we have some voices here.
Hello, my name is Kajal. I can read any text you type here.
So these things you can integrate with your like product if you want, and then use it. We have other voices too.
Hi, my name is Aditi. I can read any text you type here.
You can alter the scenes too, like this is a sample one. So if I listen to this.
Hi, my name is Aditi. I can read any text you type here. Wow,
You can see, right? And you can have, for example, hello, welcome to Burger King web app. If I play with this, change the voice, I will go with some other thing, Australian, we'll go with the male voice, I'll listen to it.
Hello, welcome to your Burger Booking web app.
Just a little bit fast, we'll go with the neural one.
Hello, welcome to your burger booking web app.
And you can have other languages too. Instead of English, you have Indian language, Hindi only, and you can go and like you can restore to default text, so it will play that in the default language itself.
मेरा नाम काजल, मैं आपके द्वारा यहाँ टाइप किए गए किसी भी वाक्य को पढ़ सकती हूँ.
Right, so it seems like lifelike speech, right? And you have other languages too, so if you want you can use it. For example, you have Japanese too, and let us listen to it. For example, yeah, we'll go with this and listen. So that's what.
こんにちは、たくみです。読みたいテキストをここに入力してください。
Sounds good, right? So this is how you can integrate this for your application. If you want, you can opt for this using Amazon Poly, and you have other voices too and other languages too. So please check this. So we'll go with German and then wind this and move into the next one.
Hallo, mein Name ist Vicky. Ich werde jeden Text vorlesen, den Sie eingeben.
Good, right? Yeah, that's about Amazon Poly to create lifelike speech using deep learning. And yeah, so next we are going to cover just one of the important and interesting one, which is called as Amazon Deep Composer. So as the name is itself suggesting, it is for composing, which is music. Okay, so AWS Deep Composer gives developers of all skills level a creative way to experience machine learning and get hands-on literally with a musical keyboard and the latest machine learning techniques to compose your own music. So the thing is, they are providing, like, if you want, you can buy a keyboard from them, music keyboard, and you can directly attach with your AWS, and whatever tune you are providing, you can get the notes there. So it also has a AI which like automatically generates some more tunes to your tune. So it is going to be a little bit interesting. You can start composing. Apart from that, you have your console here. You can add some sample musics, or you have a keyboard here itself in the virtual. You can use that too and compose. And what you can also do is, with that you can ask the AI to further transform it. So it uses something known as we know, right, reinforcement learning. So it's a different domain, which is like generative AIs, etc. We'll explore that using Deep Composer. So these are called as generative AI. So previously we have seen some machine learning parts, which whatever we are giving based on the data, it is going to give you the output. But these are generative things, which means based on the data, it is going to produce new results from what it has been learned. So that's what called as generative. Okay, so you can like opt for this keyboard to Deep Composer keyboard. And apart from that, if you want, you can get started to learn how machine learning to compose music. So we'll start with learning about the generative AI. So we'll get started. So we know, right, the machine learning, the AI, where the subset of AI is machine learning, where in the types we have reinforcement learning, supervised learning and unsupervised learning. So in supervised, we know we try to split based on the labeled data, and in unsupervised you don't have labels. We'll try to find groups or clusters. And in reinforcement learning, it's a technique where we have an agent and we have an environment and we have an action to do it, and if it is performing well, we'll be giving reward to it. So based on the reward, whether it is good, then it means it following correct. So if the reward is bad, then it is going to decide to change the action and try to opt for this. So we have some of the deep racer. We'll see that in the next session, which is called as AWS Deep Racer, which is like designed in a way to automatically follow the track path based on the reinforcement learning. They are actually conducting a virtual race event too, so you can check that. And yeah, so if you go next, these things, fine. Generative AI is like, it is going to produce some new things like the images, music or text. And yeah, so we have some of the sample music. So they are telling these are some of the musics which is generated by the AI, generative AI. See here, this Musgan has produced a jazz music. We'll listen to it. So they are telling this music is generated by the generative AI, so not a human composition. We have this, okay, this too. So this is based on one composition from 18th century, so it is mimicking that too, okay. And yeah, when you talk about generative AIs, we have something like generative adversarial networks, variational autoencoders, and autoregressive models. So these are like a different domain. You can explore this too. And with that, what they are trying to do is they are giving the input, which is the musical input, and they are having with the generative adversarial network GANs, okay, they are having a generator and the output will be given. So based on the training data set, it is going to have a discriminator as true or false, and some loss value is passed here and there, and it is going to generate, okay. So generator within a GAN in a machine learning model that's trained to produce seeming output which is realistic, and it's like an orchestra. It trains, practice, and tries to generate polished music, okay. And we have the discriminator. It's another machine learning model which is trained to take an input and classify whether the input is real or generated. So it judges the quality of the output and tries to achieve the style of music that it has been trained on, okay. And yeah, so we have this GANs, and let us see how the computers understand music. So for a machine learning model to be able to interpret and generate music, it's important to represent the music in a format which preserves the details, right? So instead of producing a sound file, machine learning produces details, so reproduce instruments and music tiles. So we'll see that. See here how it is like noting it down. So it is using the pitch, okay. Pitch is a tone that is assigned to a relative position on a music scale. So we are starting at 0, lowest, and then highest is 127. So in that range, okay. So in the deep composer they have between 41 to 72, and with that, like, you can listen to it. So the pitch values, based on it, it is understanding the music, okay. And you know, right, whatever may be your data, if you want to go it and use it for machine learning, numbers, you need numbers, so you have to find a way to convert it into numbers, right? And it also uses the velocity, how hard it is pressing, right? See here, light music and the sound of it, you understand, right? The pitch and velocity will determine, and we also have the tempo, and this is tempo 200, the speed of it, right? So with this too, and with all these things from different instruments, it is going to stored in the MIDI file. So this MIDI is a format which is industry standard by computers to record and store music, like MP3. This is one format. So if you want to use any file, you want to go with MIDI format, okay. So with that, it is going to use. So what you have to do is, if you want to generate a music, you have to go with train a model, understand, and then create a composition. So you can choose the predefined or a pre-generated. We'll go with the music studio. So let me select a sample music I'm having. We'll explore that, okay. I have some of the 3 compositions practicing I have done. I'll just delete it and recreate freshly. So I'll start composing, and you can directly record here, okay, or you can attach your keyboard if you have, or you can use some of the samples here, or you can import a track too. So let me just import a file which should be MIDI format files, okay, and it should be below 10 KB. I'll try to get the files. I think this is a file, yeah. So it's the Avengers music. I have converted into that format, and the size also should be correct. And yeah, this is the music. It is not going to be that much accurate compared to the original music. It's a keyboard version. I have tried to convert it in this MIDI format. So we'll play that first. First, let us listen to the original music. And you can see it is around 13 seconds, I think so. Totally you can find the output is around 16 seconds I'm having, and the music is stopping in between, okay. And this is what the BGM is starting. So we'll use this music, and then I'm going to press continue. So if I'm okay with that, I can press continue, and you have like notes are automatically added using this ARCNN or removed from your input track based on the parameters. Okay, and GAN are genre based accomplishment tracks. Okay, and you have transformers which is added like 20 seconds. It will extend your music. Previously we had 16 seconds, right? So if I go with transformers, then it will add some more music based on what it has learned previously. So we'll go with this first and try to get some output. So you can, this is like you cannot get that much accurate and good, but it will try to create somewhat good. Okay, so we are giving some of our inputs and trying to do it right. So we'll ask it to continue. We'll wait for this to generate, and you can see the inference and download it later. So it is preparing, and we'll wait for this. Yeah, it has been completed, and it seems like it is having more than, yeah, from 16 it has added to 28. So if I listen from in between, we'll skip this and play here. So let me play from here. So after 16 it's the generated music, you can see, right? So this is actually generated by this transformer. Okay, so you can go and select the instrument too. So if I want, I can go with something else. So I'll go with strings. Yeah, I will go with this and try to listen to it. This is actually the original one turned into that voice, but this is generated. Okay, it's not that much good the output is, but still it is generating, right? And yeah, you can create your own to learn reinforcement learning and try to build something like this, which is actually good compared with that. And if you want, you can go with like you can extend this again if you want. I will go and change some of this. Apart from this, we'll try to change this. Okay, I'll continue with this. I think the input track is imported track, my file. I will try to go and add some more music with some other thing. Okay, so the same thing which we have used previously, the 16 second. So I'll go and continue with this, and we'll go with genre based, and you can select the algorithm and then which music you want. I want it in symphony, so I'll go and continue this. So this is going to generate that music, so I will try to analyze it. And this is the thing. So with your original thing, it is going to add some more musics, and you can find whichever music that has been added. So if you want, you can mute that too. Like this is like a trial, so it is not that much going to be the output is that much good to hear, but we'll try to listen to this and try to mute something. So if you want, you can keep some things too. I'll play it. So it is like adding some more instruments behind. So if you want, you can add, and we'll listen to these two or this alone. We can find, yeah. So it is having a French horn. Okay, so you can like play with this, and whichever is good, you can go and generate that file. Okay, I'll mute this and play this alone. So it is like based on the tune, it is adding further mute instruments to it, right? So you can change the algorithm too and then check. Okay, and yeah, you can go and continue and save this if you want. And this is actually really good task, but they have to improve it furthermore. So that's what about AWS Deep Composer. Starting with Amazon Deep Racer. So this is like similar to Amazon Deep Composer. So this uses reinforcement learning, and we may not go hands-on with this, but let us learn and discuss furthermore about this Deep Racer. So even like this is kind of automotive car, like you have a simulated environment, or you can have it physically too. So they are even conducting a league for this race, okay, from AWS. And who is going to drive this remote cars? Okay, like a remote car, we are having something, right? So the image will be looking like this. Okay, so this is a physical one, and this is a simulated environment. And who is going to drive this? Like whether it is like controlled by someone? No. Okay, so you can create an algorithm or model, okay, using reinforcement learning, and make it accurate that it can follow the track and go in this race. Okay, so you can have it in a simulated environment, you can test it, and whenever they are conducting a league, you can go and if your algorithm performs that much well, you can buy a physical one and then participate in this league itself. Okay, and so Deep Racer is a compact race car developed to facilitate the exploration of reinforcement learning by developers and machine learning enthusiasts. So it operates autonomously at a 1 by 18th scale and is integrated with AWS suite of machine learning services. So user can train and evaluate reinforcement learning models in a simulated environment, participate in global racing leagues, and engage in live events also. Okay, so we'll go and see much more about it in the console. So let me just go with Deep Racer. Yeah, so it is supported only in the North Virginia region, US East 1. So if you want to use this, you have to go in that region. So these are some of the services which is available for particular region alone. Test basis they will be releasing, not for every places. And so this is what the Deep Racer League is. So you can create and you can order this evocar which uses cameras and sensors to run it. So we can go and create a model. So here you can learn about it. First let us learn the basics. Okay, and we may not go hands-on with this, but you can go and create a model, train and evaluate it. Okay, and you can upskill it, and you can also join the league. So we'll go with learning the basics by taking this course. Yeah, so reinforcement learning is also a type of machine learning where an agent explores an environment. Agent is someone who performs the task. Okay, and like this car, and the environment is something like the track it has to go. Okay, action is something like whatever it is doing, whether it is going front or back or left side or right side, whether it is moving or not. That's what called as an action. And the outcomes can be good outcome or bad outcome. So based on it, some reward will be given. Whether if the action is good, then some huge reward will be given. If the action is not that much good, then the reward value will be reduced. So with that, it can understand that it's not performing well. So it will try different combinations. So that furthermore, with time, it will learn over time and be able to identify which actions leads to the best reward. Okay. And in reinforcement learning, an agent interacts with the environment with an objective to maximize its total reward. Okay, and this is what called as an agent who is going to perform that task. And here it is a vehicle, right? And the environment is nothing but the track that defines where the agent can go and which state it can be. And the agent explores the environment to collect the data to train the underlying neural network. Okay, and it's based on neural network reinforcement learning too. So a state is something like at that instance. Okay, for example, if car is in this position, in that place, what is the state it is having, which means the snapshot of that environment at that point in time. So it is called as state. And for AWS Deep Racer, a state is an image captured by the front facing camera on the vehicle. So in the front, what it is the image it is getting, so that's what going to be the state of it. And next, the action, so it is making, whether it is responding, how much it is moving, etc. And the reward is like the feedback which we are going to give. So whether it is good or bad, based on it, it will improve it on its own with further over time. Okay, so the training part, as we know, this will take some time, which means like over the time it will learn the best way. Okay, so which means it is going to learn all the wrong ways and then learn from it. Okay, so training is an iterative process. In a simulator, the agent explores the environment and build up experience. The experience collected are used to update the neural network periodically, and the updated models are used to create more experiences. So with AWS Deep Racer, we are training a vehicle to drive itself. It can be tricky to visualize the process of training, so let us take a simplified example. See here. So for example, this is an environment. Okay, just consider this is going to be your overall environment, this is going to be your agent, and it has been splitted into parts, and the reward is going to be get. For example, in this state it is going to make some action, so it can move either side, okay, and it can move forward. So what is the best way, guys? So if it want to reach us this finish line, then this can go on a straight path, okay, with very fast it can reach this and it is going to achieve that. Imagine it is going this side and then coming back here this side, so going in zigzag movement is not a best way of the output, right? Here the situation is straight road, so it want to go straightly, okay. So how are we going to make it work in that way? So I want to define the model. So if you go in this path, okay, you are getting a lot of good outputs. This is what a good is. So what I'll be doing is, this is going to be our reward. See here, if it reaches any of these places, there won't be any reward, okay. If it comes to this path, the reward is very minimal, which is 0.2, okay, and if it goes in the correct path, then the value it is going to get as a reward is 2. So its primary output is to increase this reward, right? So what it will try to do is, it will try various combinations. First it will start with something like randomly, let us go with here and then here and here and here. So it will try to achieve somewhat, it will reach here, but the overall the reward is going to be very low, so it will try to improve furthermore. So the next time it will try to take a different path, and now if it achieves some good output, then it is going to repeat that output and do further variations in that. So likewise, if it keep on performing over time, it will learn that if it goes in this path, then it can get the maximum reward, okay. See here, so it will try different combinations, right? Here and all it is not getting that good output, so what it will do is, it will try to go in this path where it can reach some good output. See here, it is now trying different combinations. So these are some of the simple examples how it achieves. See here, then it is going to choose the maximum path. It is getting somewhat around 2.4 and then going into the wrong area, and then now see here, it is not going into the wrong area, so it's trying to do the task here itself, where it is getting somewhat good output, but still it can improve, okay. So over the time it is going to increase, right? And that's how this thing, like once it is completed, it can reach the entire thing, okay, and the score can be the maximum with this value if it goes straight. So over time it will increase. And regarding the reward functions, okay, so it has lot of parameters to for this movement. For example, whether it is a physical one or the emulated one, so it's like a car, right? So it has to be having the position of the track. So these are all the factors which is going to decide how it is going to take some action. And the heading, okay, since like previously we have saw some simple example, which is a simple environment, but a real-time environment won't be this much simple, so it is going to be a little bit complex. So in such case, so it has the parameters such as position on track, heading, waypoints, track width, center line distance, like whether all wheels are on track or not, true or false, and the speed, steer angle to determine the steer, okay, which means to rotate, right? Yeah, and these things are going to be your parameters. So totally there are 13 parameters, like when you create a model. So when you put it all together and train it, okay, see here, this is for stay on track function. So if it stays on track, then the reward is going to be high, okay. So if all wheels are on track and if everything is fine, then the reward it is going to get is 1. Otherwise they are giving very low reward, okay. So it will try to achieve this point automatically. It's like for every thing which had like the parameter it has to consider, they are going to give some rewards, and the reward is going to be high only when it performs well, right? And this is what the basic thing about. So and you can go and create a model, so you need to have like further more knowledge about creating reinforcement learning projects, then you can explore this part, okay. So if you are going to create this is going to be cost you a lot high, so please be careful with that, don't just play with it, okay. So if you really have idea about the reinforcement learning projects and you want to explore it, this part too, then please have that knowledge in your mind and then go and try with this or play with this, okay. So that's it about AWS Deep Razor, like reinforcement learning. So this is next level, right? And then we are going to see something known as Amazon Textract. So Amazon Textract is a machine learning service that automatically extracts text, handwriting and data from a scanned document. So you can upload a PDF and or any kind of document, and in that whatever thing you are having, it is going to take it. So you can take or extract from tables, you can identify signatures, tables and forms, etc., or simple text alone you can get it. So this goes beyond simple OCR, which is the Tesseract optical character recognition, to identify, understand and extract data from forms and labels too. And yeah, we'll go and see one hands-on with Textract. Yeah, Amazon Textract. So let us go and try Amazon Textract first. So this is a bill. First we'll go with the sample document and then we'll use our document. See here, from this bill it is getting the expenses, right? From the table it is taking everything, so you can see the details. So you can go and choose what is a sample document. So let's go and get a vaccination card. Okay, the dosage, COVID-19, Pfizer. So it is telling you, like, even it is even taking the seal, something like that, which is printed in this way, right? All those things are like taken, so you can extract this, download this result too. We'll go with the loan application form. Okay, this application form, the name, etc., all the details it should get, and it will try to extract all the informations. Okay, and yeah, this uses like the image processing, OCR, and then NLP to take the things exactly. You can have other things too, you can play with this. Okay, you also have, this is analyze the document, you have analyze expense, which is to calculate the expenses. So what are the expenses available, so it will take that and give you separately, like the numerical things. Like you can use an invoice too, so if you have one, you can go and try with that. You can upload a document and choose it. So if you want, you can choose any document and use it here, but it should be like when you go for analyze the expense, the size, it should be like less than 5 MB, and it should be in this format. So if you go for analyze document, in this you need to have less than 11 pages and smaller than 5 MB, or you can go with bulk document uploader. Okay, so I have something here, you can go and upload documents too. Okay, you can take it from S3 or you can directly upload from your system. So let me upload it. Okay, so I'll go with this resume sample. Okay, yeah, so which is a feature you want to select, whether you want just a raw text from it, tables, queries, forms, signatures, expense analysis, etc. I'll just go with this OCR now. So I'll do the start processing. This should starting now. Yeah, this is processing now. So let us go and get it once it is done. And you cannot directly delete it. See here, the output files will remain for 7 days till you like when you created it. It is going to be there for 7 days. So please don't search for delete options. It will be automatically deleted after 7 days. Okay, yeah, it's processing. So you can see, right, I have previously done, and it is persisting. If you want, you can go and click it and then download the results. We'll download our result. Okay, we'll wait for that to complete. It's processing. Let it process and we'll continue with that. Yeah, it's ready for download. Once it is done, you can go and select it and then download the results. Okay, so it is going to get downloaded, and once it is downloaded, you will be getting a WinRAR file where you can extract all the outputs. For example, so if I open this, see here, so I'm having the JSON response, CSV file, the raw txt file. So this is what it has been extracted from that sample resume. So we can see all the text has been extracted like we expected. And you also have a data set kind of format, a CSV file, where it will give you the confidence score and the text it is extracted. Okay, and it's also giving you what type it is, right? So all the details, you can extract it, you can use it for expense too. So please just play with it, and if you want, you can use that too. Okay, this service. So all these services, they are like providing for like any business requirement. So whenever it is required, so instead of like they manually doing it, they can opt for AWS AI services. Okay, and yeah, that's about Amazon Text Extract, which is used for extracting